Hi everybody, it's been over a year now that I've had this Golden Motor 10 kilowatt BLDC brushless DC 48 volt 10 kilowatt motor. Just wanted to go over some of the things I learned, just give an overview video of all the components that are required, and I'll just pass on some feedback here at the end of the video. Reverse. Forward. I don't know, this is kind of a cramped area here, but... So the elements of my electric motor conversion, just to kind of go over how this all works, is first off in the back you can see I've got a mound of batteries. So there's 2, 4, 6, 8, 6 volt batteries. Those are basically they're lead acid. Like I said in one of my previous videos, I talked a little bit about lead versus dry cell versus the lithium. And I think the lithium's the right way to go, but I didn't really know enough about batteries, and I didn't want to spend the money on that while I was still figuring out everything. So I went with this, and I've got basically, if I run it at 25 amps, I get 440 minutes. And what I found last year was that at about 22 to 25 amps output, I'm able to get about 3 knots. And that's fine in the marina, but if I was in an emergency situation where I need to run the motor hard, essentially I'd be running the power draw faster than what the batteries are rated at, and they'll just get a little hot, and it damages the batteries over time, so they won't last as long. So that's kind of why, like, certainly in a short burst or something, you can certainly go ahead and do what you got to do to get out of something if you're maneuvering, but you really don't want to run them more than 25 amps. So last year I had a pulley system, and I had a 1.92 to 1 pulley, and this year I'm trying direct drive to see if that lowers my RPM. Well, I know it will, but I just want to know if the motor has, if it's too torquey for the motor, if the motor's going to overheat. I've seen other boaters do the direct drive with these 10 kilowatt motors. It's got a lot of torque, so I'm pretty sure it's going to be okay, but I'm just not too sure if it's going to run a bit hotter or not. So so that was why I changed this configuration, which meant I had to weld this. I made this mount here basically to get the motor up to align properly. And then up at the top here, this is actually the Vector controller. So I've got the Vector 500 amp controller, and this controller allows me to do you can hook up different throttles to it. You can configure it a little bit. This is the Golden Motor, the Golden Motor product. And the motor itself is the liquid cooled 10 kilowatt. I don't have the liquid cooling set up yet, but I am going to be working on that. So the power gets its feed from the batteries. So I've got the battery feed coming in through these cables. I've got a shut off here, a master shut off. And then there's a line here for my E-lock, which goes out to the helm station, where I have a shut off, so that way you can depower the controller without, or down at the helm station, and I can lock it out. So it's got on the Vector controller, it's got a little plug here. This is what I was using to access it with the software, and then this is all the main sensory data. So right now, because I was just installing this, I've got to clean up and nail the wires down, or not nail, but secure them, fasten them nicely. I put a bridging block here with a couple of cables that go up to the helm station for the throttle control, the reverse, the E-lock, and the regenerative braking, or just brake actually. if the propeller starts to turn on its own, you can put the e-brake on basically, and it locks it, so basically stops it from turning. So last year, because I was using this pulley system, it's basically a grooved timing belt that you'd put on the inside of an engine in a car. So like this thing, just with the proper tension, was not going to slip. I put this on, but because of these grooves, it would make like a grinding kind of noise. I guess that'd be cool if it was in a car and you wanted to be a muscle car, but being a silent e-boat, especially a sailboat, it was just kind of loud and disturbing. So that was one of the other things I was trying to figure out. Well, how can I make this a little quieter? And so going with the direct drive, I don't have any of these grooves on the belt to hold the pull or to create the force to get down to the propeller. So I'm pretty sure that this is going to be a lot quieter. So just carrying on with my talk here. So coming out of the controller is a 3-phase controller. That's why there's 3 colored wires here going to the motor. And the golden motor itself, actually I believe has 2 stators. That's why there's 2 sets of wires. And you can actually parallel, you could put a second controller to run the other 2 to distribute the load. That would be one way to do that, I guess, in a high torque situation, or for some redundancy. If this failed, you'd have a second controller that you could run off. So yeah, I've so far, I mean, decent unit. A lot of chatter about regenerative qualities. I think here on the lake, I'm not sailing for long enough to really get any regenerative charging out of my motor, but that it does have that ability. The only thing is that for whatever reason, the software load that I have here installed, the controller beeps when it's in regen mode, so I haven't figured that one out yet. I'm going to have to go through the software here now and see if I can figure out how to make this quieter. That basically when you put it in regenerative mode, the controller is beeping, which doesn't make any sense. So basically the controller sends its signal down to the motor turns, it then transfers the energy down to the propeller shaft, and the propeller shaft turns. So this year it's a little bit different. Down here at the prop shaft, there's actually in behind here is another bearing. And last year I had the bearing fed down with a pillow block style bearing. This one here is just a flat flush bearing, but the couplers on the shaft are pushing against it. So I've got 2 couplers on this side and 2 couplers on the back side, shaft couplers, and those are locked on the shaft, so they can't move. And then that bearing itself is fixed to this big steel plate, so that can't move either. So when you have the pressure pushing against the water, it pushes forward on the shaft to move the boat forward. Well, the 2 shaft locks hit the back of the bearing, and it can't push it. So that's where the thrust control is in place. So when you put tension on and you rev the propeller a lot more, then what happens is the pressure comes against this, gets pushed against this board, and then you can see here the original block is down on my engine mounts, which is onto the fiberglass hull. So this whole thing just pushes and holds the pressure back. So there's actually no pressure on the motor. And that's actually this jar coupler, there is a gap in between the 2, so they don't touch. At least that's the theory. We'll see how it goes when it's in the water, if it's strong enough or whatnot, but I'm pretty sure it's going to be okay. So that's kind of like the basic setup. So you got your battery control. My system's 48 volts. It comes into the controller, and then when you run your throttle, you're just basically putting a little bit of voltage into the controller, which then opens up the primary voltage, and it cranks this motor over. So it's pretty straightforward. And then, like I said, coming out of the system, there's a cruise control, there's the brake, there's the E-lock, the throttle control, and there's one Hall sensor, which goes down to the motor. And that's where it gets sensory data like heat, rotations per minute, that kind of stuff. If it's being overworked, or if there's too much tension on the motor, it'll shut the motor So that's kind of the basic system. There's a fuse here as well in case you blow it. And I think that's probably about it from the motor side. So now I'm just going to show you some of the other systems that kind of go into that. I've done a number of videos on all the core components, but basically you need battery monitors, which is kind of a critical aspect, and then you need charging. So I'll show you how I'm getting my charge. I've got a couple of Bluetooth smart dongles. These are connected into the Victron Energy devices that I have in behind the wall here, into the in the locker. I've got a solar MPTP controller, and then a Phoenix inverter. So basically it takes the 48 volts and turns it into 120 volts. So I've got it off right now, but I always leave this one here on, the sensor, which is for the solar panels. And then my battery monitor is, I have the BMV 712 battery monitor, also from Victron Energy. After I've played with the number of, battery monitors, I'm just going to go with Victron Energy because their stuff is solid, and you know, a lot of good things, like, you know, the way they make them, they've put a lot of thought into some of the includables in there. So this is a, oh, I forget the name of that now. It's basically a bridge that sits in between the negative side of the battery system, and it injects itself in the middle and then reads the amount of energy going through it. So then the energy is sent down this cable over into the battery monitor. So it takes the energy and it sticks it here into this this battery monitor. So right now it's got, you know, a number of things that it can tell you what's going on. I'm drawing 10 watts, 0.18 amps. Battery voltage is 54.25, and right now it's telling me I can go for infinity, but I think at this draw I can go for about 10 to 14 days running this. But anyways, it's in good shape. So I'm running at 100% full. I've used 0 amp hours, 9 watts, etc. So this here is also connected to Bluetooth. I'll bring that up. And why you want this, I'm basically connecting to this via Bluetooth, is it gives you your running draw like at an instant, and I can do that anywhere in the boat. So what ends up happening when I'm connected to it and I'm running the motor, I can actually see how much current I'm drawing and how much power in watts, and then it gives me my time remaining at the current draw, which is extremely useful. So the battery monitor is a critical system for any electric motor, because you need to know exactly where your batteries are sitting. And then from the solar charger, I'm going to go over that here in a second, but you know what, because of that dongle on the side and I'm working, I hit it with my shoulder, and I can't connect to it because it resets the pin. So it's kind of a bad spot for that dongle. I think I'm going to move them, but I wasn't too sure how strong the Bluetooth was, but generally speaking, I could sit in my car and take a reading. So I'll have to reset that before I can show you that. Alright, so up here, I've got the 400 watts of solar panel, and those are Renogy brand solar panels. So far I've been pretty good with them. I had one in the beginning, and then I bought, I think it was this one, and I bought 3 more to add into it. It's interesting, this one's fading. That's the original one. They need to be cleaned a little bit, but they've been working pretty good. And then this power comes down these connector 10 gauge wire here, and it's basically going down into here, the depths of the boat. So give me a second. So in here I've got a couple things. I've got 2 of these Noco Genius Gen 2 mini banks. So when I'm on shore power and I want to do some long-term, I guess, battery health regeneration, I put these on, and sometimes it takes about 2-3 days. They're like a slow charge, and they basically they kind of level out all the batteries. So I've got them connected in there. The solar panels comes down these black cables, and it gets connected into this Blue Solar charge controller from Victron Energy. It's this one here. I've got the 150 volts, 35 amps, and right now it's like tons compared to what I have. I'm going to double up the panels, and I'm going to leave them in parallel. So, right now the 4 I have are connected in series, so they're about 80 volts, and I'm getting, I don't know, somewhere around 5 amps, something like that. So I'm going to double it up, which will get me close to 10 amps in my on a nice sunny day, and but the voltage will stay the same. So I can see I'm way below this. One of the things that's interesting to note, you can't reset this Victron Energy MPTP controller to a different voltage on the DC side. So once it's been used, it's read itself that it's a 48 volt hookup. So this thing, I have to send it back to get refactory flashed if I want to use it to a different voltage. That's just what they said. I never ended up hooking up the ground here yet. That's something I need to do. So I've got to find a way to get over into my my ship ground. So if there's a surge or anything, it just goes out through the ground and out to the sea. So one of my the shaft coupler. That's not the right word. There's I can't remember. In front of the skeg, there's a part that holds the shaft cutlass bearing, and that is actually steel in my boat, and it's bolted into a steel cable. So if there was ever a lightning storm, it would travel through that into the water. That would be the way to ground. So I just got to find that cable and connect to it. So that's the controller, and then basically I have the little Bluetooth dongle going over there to be able to give me readings from the system. But basically it gives you historical, shows you exactly what it's using, and it's actually very useful for long-term strategy because I'm basically trying to be off-grid. So just to close off this video, a rundown on the electric motor. Like I said, so far I'd say not crazy about the Vector 500 controller. Like, it does the job. I don't have any reason not to like it. It's just not intuitive in terms of the programming, and I don't understand the error codes and why they made the regenerative beep the same as the error codes. It's like a little bit confusing. So far the motor's been more than powerful. I'm pretty satisfied with the output power. It's a very torquey motor, so it's a ton of power. And so far the solar panels, they're just not adequate enough. Like, I get on a very peak day, 5 amps, 6 amps, 7 amps. We're a bit north here in Ontario, so we're not getting a lot of direct sun until the summertime. So I think, like I said, I'm pretty satisfied with all that. So if you have any questions on anything on the electric motor setup or anything, happy to answer what I can. Really appreciate your thumbs up. Appreciate you guys subscribing to the channel. It's just trying to share my knowledge out there, and no other motives or anything. I think it's good to share ideas, share what you're doing, and as you can see, my boat needs a lot of work. Anyways, again, I'm amazed that all you guys are on the channel subscribing. Really appreciate the comments and the feedback, the encouragement. Like I said, I think I've said this a number of times, but you know what? I'm not professing to be an expert. I'm just documenting my journey. And some people have piped up with questions and whatnot that get me thinking, and I go off and I do some more research on it to make sure I understand some of these concepts. My background is in IT and technology, not in boat boat overhauling, but I'm a handy guy. I've built a lot of things, did my own renovations, so I'm okay with doing all the kind of the structural things and learning about this. But it's just I'm learning as I go about it. So sharing the journey with you. So thank you again for watching. I really appreciate the thumbs up. It helps get the channel noticed, and hopefully more people get to see it and follow along the journey here. So thank you. I just wanted to say thanks again for watching. I did have a couple of things I wanted to clarify here just at the end of the video. For those that want some extra details, here they are. Number one, I just wanted to clarify that I originally was going to change the prop this year, but I wanted to do a true one-to-one test. So by leaving the shaft, the prop the same, the motor, everything, the only thing that was different is I got rid of the 1.92 to 1 ratio by directly mounting the motor onto the shaft. So my results was that at 3 knots, it depends on the days. Maybe a caveat would be everybody's prop size is different, slightly different. The pitch is different. The boat's shape, hull size. These are just my results. Okay, so that's why I kind of wanted to keep everything the same, just to see what I would get. And at 3 knots, I was using about 18 amps, and I was able to consistently run at 3 knots. Now, if I had a headwind or something like that, but just, obviously keep that in mind, but on a quiet day, 18 amps was all that I needed to run 3 knots. With the direct drive, I'm able to run 3 knots, and that only took 10 amps. Like initially to move the boat, it moves more, but once the boat is moving, I only needed about 10 amps. So I had a significant savings. So that's basically the 1.92 to 1 translating into a 1 to 1. I had, I'm not quite getting half. So, half would have been 9. It's actually maybe 10, 11 knots, amps, somewhere in there, 10.7 I think it was. So there's maybe about a 10, 15% more power required because of the higher torque. That's kind of my guess. And then the other thing is that the importance for my solar panel, I made reference to wanting to add 4 more panels. By getting the voltage on the panels is 80 volts, and I get about 5 to 7 amps out of it. On a good day with a lot of sun, I'm getting 7 to 8 amps, but on typically I get 5. So getting it to 10 amps at 80 volts, my batteries are 50 volts. So there's about a 40% increase from 50 volts to 80 volts, roughly. So that means that I can get 40% more amp being put into the batteries from 80 volts, because it basically converts the energy is in the form of watts. So because of the difference between the batteries being about 30 volts, that 30 volts is actually the amount that it can push energy into the batteries at. So getting it to doubling up the panels, I'm effectively going to get 10 amps of 50 volts into the batteries. So another reason why that's important is that based upon my study now on my direct drive, or even before I needed 18 amps, but I can almost run with 800 watts coming off those panels at 80 volts at about 10, 12 amps. I'm guessing that to get it down to 50, I'm going to have 40% more power. So I should be around 14 or 15 amps with doubling the solar panels. I should be able to run the motor right off the panels. Like, I'm not even going to need the batteries. So on a peak day with full sun, I don't think I need batteries to run the motor. So in other words, I'm not really going to drain the batteries. So I'll be able to use this motor at a much longer distance during peak sun. So then I'll only need the batteries when my voltage drops down, or if I push the motor more than 10 amps. But I can get 3 knots, which is like fine for me. I'm not a speed demon here, I'm a sailboat. So anyways, that's kind of a big thing for me. And then maybe the last thing I just wanted to clarify, I did kind of knock the Victron 500 controller a little bit, but it's not so much that it's not working, it's working fine. I just wanted to clarify that it's more like somebody who is not a human, or sorry, human. What do you call it? Human engineering, ergonomics. Sorry, that's the word. So if you were to design software with a human interfacing in mind, you would design it to be user friendly. And that's not how this was designed. This is designed by an engineer who likes square boxes, you know, just to use that phrase. So that's what I find challenging with it. I don't understand certain things. It's not intuitive, but it does the job. So, you know, from an execution standpoint, I push the throttle forward and it moves. I can't find a manual for this Victron controller that I understand. Like, it's not written in a way that's intuitive. If you've got it, there's a whole variety of throttles out there. I switched mine from a Hall throttle to a what do you call it? A parabolic throttle. The one there that I showed with the big steel stick, and you know, I couldn't figure out how to do it. I had to call and get support from Golden Motor, and you know, and they're great. You know, they help out. You know, Mooj over there. I just want to say another shout out to him. He's been great. I just didn't understand what to change or why, and you know, some better attention to, you know, a human using the system would go a long way to making that a better product. It's kind of like why I picked Victron Energy instead of all the other products. It's just, they give you everything that you need. It's intuitive to use. It just works. You know, and if I want to make a setting change, it's just simple to understand. Like, it's intuitive in terms of how it is. So that was all I wanted to say. You know, this video wasn't sponsored in any way by Golden Motor. I just think that this particular motor is working well. So I just wanted to do a shout-out video for that. And it's been a year. Learned a lot. And, you know, if anybody has a question that they want to post here in the video channel, I'll be more than happy to post an answer. So thanks for watching, and I'll see you in the next video. Mooj over at Golden Motor was great. They called me back and helped me sort this thing out. At least got me pointed in the right direction. So way down under controller functions, speed throttle type. This was set to Hall effect sensor, which I couldn't get at before because of this software is glitchy. But there was a way that I got that. There we go. So I was able to select potentiometer throttle type, and then I was able to upload it to this system, and then I disconnected the cruise because I don't think and the brake, actually the regenerative braking, I don't know, I'm going to have to figure out what to do with that. But basically, after disconnecting all of the cabling that I ran over there, so what I ended up doing was disabling all of the previous cabling that I had run all the way to the back, and I had to take off the brake. I put the E-lock into the cable that it came with, because it was either that or cruise, because it was a male plug and this is a female receptor. So it was either the E-lock, which kind of made sense to me. So then what ended up happening was now my power button works here, and I'm able to control that through that switch, and then this all of a sudden starts working. So you can see here, forward and backwards. So I'm able to move that now in both directions with that throttle. So I was like, oh yeah, okay, right on.